Today, we will learn about proportion. Can you tell what is the meaning of proportion? Think for a while. Absolutely correct. We can understand the word proportion as equal ratio. Equal means same. From this, we can derive the meaning of proportion as same ratio. So let's learn about proportion. Here is a picture whose length is 5 inches and width is 7 inches. Suppose we have to make it bigger. In order to make the picture bigger, we can increase its length. Then, the length of the picture will increase, but the width will remain the same. By doing so, the picture will not look like the original picture. If we keep the length as it is and increase the width, even then the picture will not look like what it was before. Can you tell how we can increase the size of this picture so that it looks exactly like the original one? Think a while. Let me tell you. If the ratio of the length to the width of the original picture is equal to the ratio of the length to the width of the bigger picture, only then the picture will look like before. Here, the ratio of the length to the width of the original picture is 5:7. If both the length of the picture and the width of the picture is increased by 2 times, then the ratio of the length to the width of the picture will be 10:14. By doing so, the picture will become bigger in size, but it will look exactly the same. Since the numerator and denominator of 5:7 is multiplied by the same number, we can say that 5:7 and 10:14 are equal ratios. If two ratios are equal, then we can say they are in proportion. We use these symbols to denote equality in proportion. Therefore, we can write 5:7 is equal to 10:14, or 5:7 is proportionate to 10:14. Order has great significance in proportion. Here, 5:7 is proportionate to 10:14 because 5/7 is equal to 10/14. We cannot change the order of proportion and write it as 5:7 is proportionate to 14:10. Can you tell the reason for this? Think for a while. Let me tell you. This is because 5/7 is not equal to 14/10. Therefore, the quantities should be expressed in the proper order of proportion. Each quantity expressed in proportion is called term. So the given proportion 5:7 is proportionate to 10:14. 5, 7, 10 and 14 are terms. The first and the last terms among these terms are called extreme terms. For instance, in the given proportion, 5 and 14 are extreme terms. Similarly, the second and the third terms among these terms are called middle terms. For instance, in the given proportion, 7 and 10 are middle terms. Let us understand proportion with another example. Tina and Shirley have made 7 garlands together. They earned ₹35 by selling them. Since Tina has made 4 and Shirley has made 3 garlands, then how many rupees should Tina and Shirley get? We can divide 35 rupees into 2 equal parts. Then each part will be 17.5. In this way, Tina can get 17.5 rupees and Shirley can get 17.5 rupees. But will that be correct? Think for a while. You've got it right. This will not be correct. Since Tina has made more garlands, she should get more money than Shirley. This will be correct only when Tina and Shirley get the amount in the same proportion in which they have made garlands. To know the amounts to be distributed to each of them, we need to divide 35 rupees in such a way that the ratio of money received by Tina and Shirley should be equal to the ratio of garlands made by Tina and Shirley respectively. This means out of 35 rupees, 4 parts go to Tina and 3 parts go to Shirley. Therefore, the total number of parts divided is 4 plus 3, which is equal to 7. Thus, in total 35 rupees, 4 by 7 parts belong to Tina and 3 by 7 parts belong to Shelley. So Tina gets her share into total amount, which is equal to 4 by 7 into 35, which is equal to 140 by 7, which is equal to 20 rupees. Similarly, Shelley gets her share into total amount, which is equal to 3 by 7 into 35, which is equal to 105 by 7, which is 15 rupees. Thus, out of 35 rupees, Tina should get 20 rupees and Shelley should get 15 rupees. Only then, 35 rupees can be divided in the ratio of garlands made by them. Hence, the ratio of the amount received by Tina to the amount received by Shelley is 20:15. Are the ratios 4:3 and 20:15 equal? Think a little. Absolutely correct. If we divide the numerator and the denominator of 20:15 by 5, then we get the ratio 4:3. Therefore, we can say that 4:3 and 20:15 are equal ratios. That means they are in proportion. So, we can write the proportion in this way. 4:3 is equal to 20:15, or 4:3 is proportionate to 20:15. Can you give some more examples by looking at your nearby surroundings? Try and do it. Today, we have learnt proportion. In the next video, we will understand it in a better way with some more examples of proportion. Today, we will see some examples of proportion. Maria uses 12 eggs to bake 3 cakes. Sanika uses 40 eggs to bake 10 cakes. Does the ratio of the number of cakes baked by Maria to the number of cakes baked by Sanika and the ratio of the number of eggs used by Maria to the number of eggs used by Sanika make a proportion? Here, the ratio of the number of cakes baked by Maria to the number of cakes baked by Sanika is 3:10. Similarly, the ratio of the number of eggs used by Maria to the number of eggs used by Sanika is 12:40. We can write 12:40 as 12 by 40. If we divide the numerator 12 and the denominator 40 by 4, then we will get the fraction 3 by 10. That is 3:10. As you can see, that the ratio of the number of cakes to the number of cakes and the ratio of the number of eggs to the number of eggs is equal. Therefore, 3:10 and 12:40 make a proportion. We can express the proportion either in this way or in this way. Next example. Prove that 13, 39, 15 and 45 are in proportion. Represent these numbers in proportion and identify the extreme terms and middle terms. 13, 39, 15 and 45 will be in proportion only when the ratio of the first two terms, that is, 13:39, is equal to the ratio of the last two terms, that is, 15:45. So, to prove that 13, 39, 15 and 45 are in proportion, we need to prove that 13:39 is equal to 15:45. We can write 13:39 as 13 by 39 and we can write 15:45 as 15 by 45. Can you tell what we need to do to find out whether two fractions are equal or not? Think for a while. Let me tell you. In order to find this, we will convert both fractions into their simplest forms. In 13 by 39, the HCF of numerator 13 and denominator 39 is 13. If we divide the numerator and denominator of 13 by 39 with the HCF 13, then we get the simplified form of this fraction 1 by 3. Similarly, the HCF of the numerator and denominator of 15 by 45 is 15. If we divide the numerator and denominator of 15 by 45 with the HCF 15, then we get the simplest form of this fraction 1 by 3. The simplest form of both these fractions is equal. Therefore, we can see that 13 by 39 is equal to 15 by 45. That means 13 is to 39 is equal to 15 is to 45, or 13 is to 39 is proportionate to 15 is to 45. Thus, we say that 13, 39, 15 and 45 are in proportion. Out of the four terms of a proportion, the first and last terms are called extreme terms. Among the given terms, 13 and 45 are extreme terms. Similarly, out of the four terms of a proportion, the second and third terms are called middle terms. Among the given terms, 39 and 15 are middle terms. Let us change the order of these terms and see what happens. Suppose we take the order as 39, 13, 15 and 45. Then the ratio of the first two terms will be 39 is to 13, which means 39 by 13. And the ratio of the other two terms, 15 is to 45 or 15 by 45. The HCF of 39 and 13 is 13. After dividing the numerator and denominator of 39 by 13 with 13, we get the simplest form of the fraction 3 by 1. Similarly, HCF of the numerator and the denominator of 15 by 45 is 15. If we divide the numerator and the denominator of 15 by 45 with the HCF 15, we will get the simplest form of the fraction 1 by 3. Here, 3 by 1 is not equal to 1 by 3. Therefore, the two fractions are not equal. Now, we can say that 39 is to 13 is not equal to 15 is to 45. Thus, 39, 13, 15 and 45 are not in proportion. If we change the order of the terms and write as 13, 39, 45 and 15, then also these numbers will not be in proportion, because the simplest form of 13 by 39 is 1 by 3 and the simplest form of 45 by 15 is 3 by 1, and 1 by 3 is not equal to 3 by 1. Therefore, we can say that if the order of the terms is changed, it is not necessary that they are in proportion. In the same way, find some examples in your surrounding situations and check whether they are in proportion or not. Today, we have seen examples of proportion. In the next video, we will clear some misconceptions related to it. So far, we have learnt about proportion. Today, we will see some misconceptions related to proportion and the methods to find proportion. Misconception 1. Are 1500 grams is to 3 kg and 300 centimeter is to 6 meter in proportion? Some students misunderstand that the ratios of two different quantities cannot be in proportion. In the given situation, they think that the ratio of weight and distance cannot be in proportion. Similarly, some students simply ignore the units. They simplify the ratios as 1500 is to 3 is equal to 500 is to 1 and 300 is to 6 is equal to 50 is to 1. They think that ratios 1500 is to 3 and 300 is to 6 are not in proportion. Because of these two misconceptions, students choose option 2 as the answer, which is incorrect. The correct understanding is that the ratio of two different quantities can also be in proportion. To express them in ratios, we need to make the units of quantities equal. Since 1 kg is equal to 1000 grams, therefore 1500 grams is to 3 kg is equal to 1500 grams is to 3000 grams. Thus, 1500 grams is to 3 kg is equal to 1 is to 2. Similarly, 1 meter is equal to 100 centimeters. Therefore, 300 centimeters is to 6 meters equal to 300 centimeter is to 600 centimeter. Thus, 300 centimeter is to 6 meters equal to 1 is to 2. Since both the ratios are equal, therefore, we can say that ratios 1500 grams is to 3 kg and 300 centimeter is to 6 meter are in proportion. Hence, the correct answer is option 1. Whenever you want to find out whether two ratios are in proportion or not, then it is necessary to make their units equal. Let us now see how to find whether two ratios are in proportion or not. Suppose we need to check whether 12 is to 15 and 16 is to 20 are in proportion or not. Let us learn some interesting ways to find this out. We have already learnt one method, in which we express both the ratios in fractional form and find their simplest form. To do so, we find the HCF of the numerator and denominator of each fraction. Here, the HCF of 12 and 15 is 3 and the HCF of 16 and 20 is 4. We will divide the numerator and denominator of each fraction with the respective HCF. Dividing the numerator and denominator of 12 by 15 by 3, we get the simplest form of this fraction, that is 4 by 5. Similarly, dividing the numerator and denominator of 16 by 20 by 4, we get 4 by 5. Since the simplest forms of both fractions are equal, we can say that 12 is to 15 is equal to 16 is to 20. That means these two ratios are in proportion. To find out whether these two ratios are in proportion, we make their denominators equal. To do so, we multiply the numerator and denominator of one fraction with the denominator of the other fraction. For instance, if we multiply the numerator and denominator 12 by 15 by 20, we get 240 by 300. Similarly, if we multiply 16 by 20 by 15, we get 240 by 300. Since the fractions are equal in both cases, we can say that 12 is to 15 is equal to 16 is to 20. Among all the methods, cross multiplication is the most interesting method. In this method, we will express the two fractions like this. We will then cross multiply them. That means the numerator of the first fraction is multiplied by the denominator of the second fraction, and the numerator of the second fraction is multiplied by the denominator of the first fraction. 12 into 20 is equal to 15 into 16. The product of 12 into 20 is 240 and 15 into 16 is 240. After multiplication, we get the LHS is equal to the RHS. Therefore, we can say that 12 is to 15 and 16 is to 20 are in proportion. Try this. There are 10 girls and 20 boys in a class. 300 flowers are to be distributed among them. They should be distributed in such a way that the ratio of the flowers given to the girls and the ratio of the flowers given to the boys is 2:1. So find out what the total number of flowers that the boys will get. Today, we have seen misconceptions related to proportion and the methods to find proportion.